Hello everyone, today we're going to talk about quadratic function. So what is quadratic function? A function in the form of fx equals to ax squared plus bs plus c. This is called quadratic function. This is the standard form of a quadratic function, and there is a vertex form, which is fx equals to a times x minus h plus k, where the coordinate h and k is the vertex. So what does the graph look like, the quadratic function? It's going to look like a parabola, which is this one, sometimes open up, sometimes look like this. Oops. Open down. So on the top, this is the vertex. Okay. When it comes to a quadratic function, how can we convert it? If I given you a function g of x equals to 1/2 x plus 2 squared minus 3. This is a vertex form, right? Which one is the vertex? Remember, our vertex is in the form of negative y plus h. Negative h plus k. So here is at and minus. So that means our h equals what? How can I write it in the negative form? So it should be x minus 2, right? Square minus 3. So that gives you x minus, which means our h equals to negative 2 and our k equals to negative 3. That takes a little bit trick that you need to twist around a little bit, because we know that a positive number, which is here, equals to negative and negative. We can write it in this way. Okay, so now I've given you a function in the form of a vertex form. How do you convert this into a standard form? So remember, a standard form, the function is going to look like ax squared plus bs plus c. Well, what we can do is we just simplify the function. So I have g of x equals to 1/2 x plus 2 squared minus 3. So let's try to solve x plus 2 squared. This is equals to x plus 2 times x plus 2 minus 3, and then we use FOIL. We got 1/2 x squared plus 2x plus 2x plus 4 minus 3. We merge the like terms. I have 1/2 x squared plus 4x. These are like terms, minus 3. And then distribute the 1/2 inside the parentheses. I have 1/2 x squared plus 2x plus 2 minus 3. And then again, we merge the like terms together. I will have 1/2 x squared plus 2x minus 1. So this is the steps that we write the quadratic function from the vertex form, from the standard form, from the vertex form to the standard form. Okay, so for every function that if they're in a vertex form, we can do the same thing, trying to just simplify it, then we can attain a standard form. Okay. So what if the function, I given you a function of a standard function, which is fx equals to ax squared plus bs plus c. How do I find vertex? Well, what we can do is we find x coordinate of the vertex, which is x equals to negative b over 2a. So that's the x coordinate for the vertex. And then how do we find y? Well, if we already located x in a line, if you find x, how do you find y? You just need to substitute x into the function y. So that means I substitute x equals to negative b over 2a into this function. So y is equal to whatever that is, we substitute in it. Okay, so now here is an example. So I have a function fx equals to 2x squared minus 6x plus 7. I want you to find the vertex of this function. So we know that the vertex should equal to what? Well, the x coordinate equals to negative b over 2a. So which one is our a, which one is our b? Well, in a standard form, we know that, hey, this is a with the negative sign, this is b, and this is going to be our c. So we just need to substitute that into the function. I have the x coordinate of the vertex is equal to negative 6 over 2 times 2, which is 6 over 4. We simplify it, we have 3/2. Alright, after we found the x coordinate, we still need to find the y coordinate. We need to substitute x equals to 3/2 into the function. I have 2 times 3/2 squared minus 6 times 3/2 and then plus 7. And then we calculate that, I got 5/2. So that means the vertex equals to 3/2 and 5/2. Okay, so how do I rewrite this into a vertex form? So now I want you to, given this function, after you found the vertex of this function, I want you to rewrite this into a vertex form. So what does a vertex form look like? A vertex form is going to look like y equals to a times x minus h squared plus k, where h and k is the vertex. So we have an a, right? A is equals to 2. We got a equals to 2, right? And h equals to 3/2. We found that. And k, vertex, equals to 5/2. So that means in a vertex form, the function is going to look like 2 times x minus h, which is 3/2 squared, plus k, which is 5/2. So this is the vertex form of this function. Okay, so do you want to try one in here? So here is the function. I'm going to give you a function fx equals to 13 plus x squared minus 6x. I want you to rewrite the function in a vertex form. So what's your step? First step. So as you can see here, the function, you need to rearrange it to attain a standard form, right? So your first step should be you try to rearrange this function. So I have fx equals to x squared minus 6x plus 13. So we found our ABC. Our a equals to 1, because there's no coefficient. Doesn't mean it's equals to 0. It means 1 times x squared equals to x squared. 1 times everything equals to itself. If it's 0, you will get a 0, because 0 times everything, you will have a 0. b equals to negative 6, c equals to 13. Okay, again, you found the vertex. The x-coordinate of the vertex equals to negative b over 2a. b equals to negative 6. 2 times a is equals to 2 times 1. So I have what? Positive 3. And then I need to find the y-coordinate of the vertex. F of 3, I substitute the 3 into the function. I have 3 squared minus 6 times 3 plus 13. This is equals to 9 minus 18 plus 13. So I have a 4. So our vertex is 3 and 4. So after that, so basically we already found h equals to 3, k equals to 4, so that our vertex form should equals to a times, which a is equal to 1, we don't need to do anything, x minus h squared plus k. I hope you got this right. So in business world, this quadratic function is really helpful for us to find the maximum or minimum, such as if we're looking for the demand and the profit. If we can find the maximum, which is the occurs at the vertex, we will find, hey, what's the maximized profit of certain products, or how can I minimize the cost of manufacturing this product. So here is an example that I'm going to show you. So here states that a local newspaper currently have 84,000 subscribers. At a quarterly charge of 13, market research have a quarterly charge of $13, and market research have suggested that if they raise the price to 13.2, they would lose 5,000 subscribers. Assuming the subscription are linearly related to the price, what price should the newspaper charge quarterly subscription to maximize their revenue? Okay, it's a revenue profit cost problem. So the revenue is equals to what? You think about that? So revenue equals to the number of subscribers times their quarterly charge, right? Okay, so since, and here they say what market research have suggested that if they raise the price to $13.2, they will lose 5,000 subscribers. So how can these linear related will get? So that means I have what? If the number of subscribers is 84,000, oh, I'm sorry, I should say, if the charge is $13, they will have 84,000 of subscribers. So if they raise it to $2, that means if it's $13.2, they will lose 5,000 subscribers. That means the subscriber is going to be what? 79,000, right? And then if they raise another $2, which is 13.4, they will lose another 5,000 subscribers because they're linearly related. So they have 74,000 subscribers. So that keep going. So how can I write this down. So that means every $2 increase in prices in subscriptions, they will lost 5,000 subscribers, right? That's the summaries. So that means if I want to make it easier, I can say that, hey, if I increase $1, what happened? If I increase $1, I will lose 2,500 subscribers. Does that make sense? Okay, so let's assume X equals to the money that they raise. The company raised. Okay, so what will be the number of subscribers? Remember, the number of subscribers is going to relate to the dollars they raise. So originally, you have 84,000 subscribers. You raise $1, you will lose 2,500. You raise $2, you will lose 2,500 times 2, right? So that means the number of subscribers equals to 85,000 minus 2,500 times X. Depends how much you raise the money. And now we need to figure out the quarterly charge. Originally, the quarterly charge is 13. Now you raise X amount of money. So that means it should be 13 plus X. So here is your revenue function. So after we got that, what did you do? You simplify it, right? By FOIL it. Let me disable this. Okay, so how do we FOIL this? So I should have this was FOIL. So after you FOIL it, please calculate it by yourself to practice. You will have negative 25,000 x squared plus 19x, 9,000 x plus 2,520,000. Okay, so this is the standard form of the function. You may see that, hey, this is a standard quadratic function. If it's a quadratic function, that means the coefficient of the x squared is our a, this is our b, and this is our c. So the vertex, the x coordinate of the vertex equals to negative b over to a, which is negative 9,000 over negative 2,500. When you simplify, this is equals to 1.8. So that means x equals to 1.8, we will reach our what? Maximum. The graph probably look like something like that. Maximum. So we still need to find x is what? X is the money that you're trying to increase, right? We still need to find the profit. So the profit is our y coordinate, which is we substitute x equals to 1.8 into the function. I have negative 25 times 1.8x plus 9,000 times 1.8 plus 2,520,000. So this is equals to 260,100. That's the maximum profit that you can get. Okay, so this is the application of the vertex. So how can we summarize it? So the model tells us that the maximum revenue will occur the model tell us the maximum revenue will occur if the newspaper charges $31.80 for subscription. And the maximum revenue is going to be $260,100. Okay. So when do we know that, hey, how do I know that if I given you an equation, how do I know when I'm going to get maximum, when I'm going to get minimum? Well, think about a quadratic function. If the graph opens up, you will get what? A minimum, right? If the graph opens down, you will get a maximum on the vertex. They're both vertex, so what determines which one is minimum or maximum? If A is greater than 0, the graph is going to be open up, then we will have our minimum. If the graph is open down, that means our A is less than 0. It's going to be a negative number, then we will have our maximum. Remember what is A? If in the standard form, A is the coefficient of x squared. If it's a vertex form, A is the function, minus h in here. Okay, so now last thing I want to discuss about is intercept. So in a quadratic function, we always have one y-intercept. Always have one y-intercept. So what about x-intercept? Well, they have three possibilities. Either they don't have x-intercept. So for open up, if you don't have x-intercept, the graph will look like that. So that means the vertex is above the x-axis. So this is a 0 x-intercept. So sometimes you might have one x-intercept. Oh, this is not the perfect graph, but you got my idea. That means the graph, the parabola, just touched the x-axis. So this is one x-intercept. Sometimes we will have this scenario that, hey, we have two x-intercept, which is in here and here. So now how do we find x-intercept and y-intercept? So for a vertical intercept, which is here, I'm going to use a blue plan, a vertical intercept. They could be positive or negative. So what do they have in common in vertical intercept? When we have a vertical intercept is when x equals to 0. Then we will have our vertical intercept. But what about x-intercept? Well, x-intercept is what? The graph intercept with the x-axis. So that means when y equals 0, we will have our x-intercept. So for example, given you a function fx equals to 3x squared, not cube, x squared, plus 5x minus 2. I want you to find the x-intercept and the y-intercept. So let's do the easiest one, find the y-intercept. So what is y-intercept? Remember, y-intercept, also a vertical intercept, is when x equals to 0. So let's substitute x equals to 0 into the function. I have f of 0, I got 3 times 0 squared plus 5 times 0 minus 2 equals to negative 2. So that means our intercept is when x equals to 0, y equals to negative 2. Okay, now x-intercept. X-intercept also, they call it horizontal intercept. So that means when y equals to 0. So f of x equals to 0. This is our y, right? So that means the function 3x squared plus 5x minus 0 equals to minus 2 equals to 0. So now we need to solve it. Well, you can use a AC method to factor it and then solve it. So this is 3x minus 1 and then x plus 2 when you factor the quadratic function. And then you solve it, I have either 3x minus 1 equals to 0 or x plus 2 equals to 0. So x either equals to 1/3 or x equals to negative 2. So that means our x-intercept is 1/3, 0, and negative 2, 0. That means there are going to be two x-intercepts. Okay, but what if you don't remember how to factor? What other method that you can use to solve it? Well, then we can use a quadratic formula. X equals to negative b positive on negative b squared minus 4ac over 2a. This is our quadratic formula. So what to do this? Quadratic formula, you just need to do is substitute a, b, c into the function and then you can solve for x. So in here, our a equals to 3, b equals to 5, c equals to negative 2. So when you solve the function, you should also get two answers and the same answer, which is x equals to 1/3 and x equals to negative 2. So either way, you can either factor it or use a quadratic formula. They're both correct. Okay, I would like to do another application problem before we wrapping up for this section. So here's a good example. So a ball is thrown upwards from the top of a 14-foot height building at a speed of 18 feet per second. The ball's height above the ground can be modeled by the equation like that. What's the maximum height of the ball, and when does the ball hit the ground? So when you're thinking about this problem, you think about what does that look like. So you have a building, something like that, and you're standing on top of the building to throw a ball. This is your ball. What does the ball's trajectory look like? When you're throwing a ball, the ball will go up and then goes down and hit the ground. This is a ground. This is what does the ball look like. So that means the ball is going to hit the maximum height at the vertex, right? And then when it hit the ground means what? Well, when does the graph intersect with the horizontal line? This thing we call it what? Horizontal axis or x-intercept, right? So that means the question is asking for two things. One is the maximum height, aka vertex, or the x-intercept. Okay, so solve the first one. How to find the maximum? Well, the maximum is the vertex. So the vertex, the x-coordinate of the vertex equals to negative b over 2a, whereas b equals to 80, a equals to negative 16. So I have negative 80 over 36, no, negative 13, sorry. when you simplify it, I have positive, right? They can both divide it by 16. So I have a 5 and half. So I have a positive 5 half. Alright, but that's not the height. Remember, t is stand for the time. H is the height. So that means we still need to substitute x equals to 5 half into the function. I have f, h equals to 5 half. So I substitute into 5 half into the function. I have a negative 16, 5 half squared plus 18 times 5 half plus 14. So that gives you the maximum height. So the maximum height equals to 114 feet. Okay, next one is we're trying to find the x-intercept, right? So they already have the function. How do you find the x-intercept? Well, I just talked about that. We can just use a quadratic function because x-intercept is when y equals to 0. We want negative 16t. You can use t. T stands for the time. Now t is the coordinate. I'm going to change all the x into t. And then plus 18t plus 14. I want this equal to 0 to find the x-intercept. How can I solve that? Again, you can factor it, or easiest way, use quadratic formula. Quadratic formula is x equals to negative b positive or negative b squared minus 4ac over 2a. So our b equals to 18 plus or minus 18 squared minus 4 times negative 16 times our c over 2 times negative 16. So we will end up have 2x or 2t. When you use a calculator, you will end up to have either x equals to 5.458 or x equals to negative 458. So what is x stands for? Well, x is our t. They just use different letter, but they stands for the same thing. Time, right? Can time be negative? No, so that means we need to get rid of this answer because we can have negative time. So when t equals to 5.458, the ball is going to hit the ground, right? So that means after you throw the ball for 5.485 seconds, the ball hit the ground. Okay, so this is the application problem. That's it for today. Let me know if you have other questions.